Hello. So this is part 2 of the video for integrating using substitution. All right. Remember our previous examples. I think this one's pretty easy to figure out what you want u to be. All right. And then you just kind of go and like, oh, okay, du is pretty easy. Tan was a little more difficult, right? Like, okay, which one should I make? Sine or cosine? And as we go through these next examples, again, this one I think was fairly easy to figure out what u is, right? That interior function. It's one way to look at that. When we look at something like this, what we want to do is have our formula sheet with us. We have to remember our derivatives and we have to remember our integral rules, all right? And this is what I have to work with. So, when I look at this, okay, what do I know? What's the integral of cosine? All right, sine, that's pretty nice. All right, and the derivative of cosine is negative sine. Okay, that seems to work. All right, so let's see if we made u equal cosine of x, and if we do that, then that means we would have u squared. And this thing over here has to be something with a du. All right? Okay. Okay, we're going to take our derivative, and that's negative sine x dx. We saw this before. We just want sine x dx. But I've got a negative here, right? Just multiply or divide by -1. I've got negative du equals sine x dx. Makes my life nice and easy. All right, negative du. I'm going to just bring that negative on the outside because I don't like it on the inside. All right, sometimes I forget about it if it's on the inside or I think it's subtraction, but you know, you get the idea. Try to do things to help you stay organized. No problem. This part's pretty easy, right? That says take u cubed over 3 plus c, and then substitute back. What's u? Negative cosine x over 3 plus c. All right, not so bad. Again, have your formula sheet with you here. So you have your derivatives and your integrals and your integral rules right in front of you. All right, let's try another one. Excuse me. This one, again, I don't think is that bad in terms of figuring out what you want u to be. I know that the integral of e to the x is e to the x plus c. All right, so let's make that my u. No problem. All right, so far I have e to the u, which I know how to do. And I need something over here in terms of du. All right. That's 4 dx, but I just need a dx. All right, divide by 4. Fantastic. All right, so du over 4. Again, I'm going to bring that constant on the outside. All right, and that's going to be the integral of e to the u is e to the u over 4 plus c. All right, what's my u? Right? My u is 4x minus 7 plus c. All right, again, once you get used to these, they're not that bad. All right, the next ones I think are maybe a little tricky, but we'll see. I don't think it's that bad, though. Okay, this is from a sample paper from IB for the new 2014 exams. And this is paper 1, right? It's paper 1. Find the integral of this. Okay. The reason I think this is a little tricky, because my first instinct when I saw this was to make u equal e to the x. Okay, I know that, no problem. Okay, but if I do that, then I get something like this. Excuse me, u over 1 plus u. And I look at my integrals and I'm like, I don't have anything 1 plus u in the denominator or anything like this. So then you kind of like, okay, this isn't the right thing to substitute. Now, what else do we have left, right? Well, I have this denominator. And again, I know, with practice you'll figure this out. Really, this is 1 over x dx. Okay? So let's imagine we instead have this 1 plus e to the x. And now I have e to the x over u. And you're probably still saying, oh, well, it's actually not that bad, right? Because I know 1 over u is natural log, and I still have to figure this out. All right, so we're going to continue this. Let's see what we get. All right, du is, right, find the derivative of this, right, that's 0, and the derivative of this is e to the x dx. Let's look at this. And dx. This is kind of nice, right? Because here's an ex dx. Sorry, I don't know why that looks like it's an exponent. Here's an ex dx. That's du, so that's a good thing. 1 plus e to the x is u, so I can look at this as 1 over u du. Right? To make it clear, if you need to see that, that's 1 over 1 plus e to the x times e to the x dx. There's my e to the x dx. There's my 1 over 1 plus e to the x. 1 over u, and we could just substitute this here. Woo, okay. So again, it is going to require you to be very, very thoughtful about what you know, what your integral rules are. You have to know how to find the derivative of this piece and see how you can manipulate the variables to get what you want here. All right, well, this makes life very nice. 1 over u, the integral of that is the natural log of the absolute value of u plus c. And what is our u? Our u is 1 plus e to the x plus c. All right, and what we're going to do, I'm just going to derive this real quick so you can see that this works. So what did we have? We had the natural log of 1 plus e to the x plus c. And if I want to find, let's say that that's y. And if I want to find the derivative of that, okay? Chain rule, right? Okay. The derivative of natural log is 1 over, all right, whatever is inside, okay, times, and what's the derivative of the inside function? The derivative of 1 is 0, the derivative of this is e to the x, plus, what's the derivative of c? It's a constant, 0. And this gives us that. All right? So you can always check it. Last one. Sine of 3x, cosine 3x dx, find the integral of that. All right, do you make u equal to sine of 3x, or do you make u equal cosine of 3x? Let's see. Well, I know the derivative of sine is cosine. That's kind of nice. That gives you no negatives or anything like that. So I'm going to make u equal to the sine of 3x. And so far I've got the integral of u, and I need a du over here. Okay. And in order to find the derivative of this, I have to use, again, I have to use the chain rule. Okay, the derivative of sine is cosine of 3x times the derivative of 3x, which is 3. Okay. All right. Here's my u. I have to find something to substitute in there. All right. Well, there's my cosine 3x. There's my dx. I got to get this 3 over here. Okay, no problem. Okay. Aha! Cosine 3x dx. Substitute that in here. Again, I'm going to bring that constant out. All right. And this is actually kind of nice. Because finding the integral of this is simply, all right, u squared over 2 plus c. And so, what's u? That is sine squared of 3x over 6 plus 3. Okay? All right, let's derive this and see if we get back to this. Okay, so I'm just going to copy that. Let's go over here. And if I ask you to derive this, it will say that that's y equals the derivative of that. Okay? Again, there's a lot of things going on in here. Okay, so what I'm going to do is I'm going to take that 1/6 out there. And what I did was, this is really, you can use the chain rule like 3 times here, right? The main function is we're squaring something. Right? This is really take the value of sine of 3x and square it. Okay, then the inside function is sine, and the inside function of that is 3x. So what that says is find the derivative of the main function using this as my input. So 2 of sine of 3x times the derivative of this thing, the derivative of sine, using this as my input. All right, derivative of sine is cosine. Okay, and then finding the derivative of our innermost function. All right. Make this a little more organized. Can I do this? Just get that guy. Yep, let's move you over. And that's 3. All right, let's see what we have. All right. In the numerator, I have 2 times 3, which is 6. 6 divided by 6 is 1, leaving me with simply sine of 3x times cosine of 3x. Again, the derivative of a constant is 0, so plus 0. All right, and this does bring me back to my original piece. Again, this is 4 marks, which indicates they would like you to do this in about 4 minutes. Checking is going to probably take a little longer, so if you have time, it's a good idea. And if you don't, you just have to be really secure in how you do this substitution process. Okay? Again, this is just a matter of practicing different ones and really having your formula sheet with you so you know what you can do when you make your substitutions. All right, well, happy integrating. Thanks for watching.